And this question is given that two planets of radii in the ratio 2:3. So we can write their R1 by R2 are like 2 divided by 3 or 2:3. Made from a material of densities in the ratio, we can take it as rho 1 by rho 2 is equal to 3 divided by 2. Then the ratio of acceleration due to gravity at the surface of two planets is. So over here we need to write the value of acceleration due to gravity based on that density and radius. We know the relation is gm by r square, but here rm is to write in terms of density and radius. So we can write g into mass can be written as density into volume. Volume can be written as 4 by 3 pi r cube, the whole divided by r square. So we can cancel this r square and 1 r square over here. So this equation is going to be g into rho into pi 4 into pi into r square r divided by 3. So there is a relation between g and other parameters. But in this question, our aim is to write it only in terms of radius and density. So we can take it as other parameters are constant and it is directly proportional to r and density rho. So we can write the value of g1 by g2 is going to be r1 divided by r2 into rho 1 divided by rho 2. So this we can write it as r1 by r2 is given as nothing but 2 divided by 3 and rho 1 by rho 2 is given as 3 by 2. So they will get cancelled and you will get the answer as 1:1 or 1.